Getting ready for algebra. Simplifying expressions. With me, Catherine. Expression or equation. What's the difference? Well, an expression does not have an equal sign, and an equation does have an equal sign. For an expression, we're not actually solving anything, we're just simplifying. In an equation, we're going to find the answer for a letter. In this video, we're only going to deal with expressions. So let's get started. First, we have to define the different parts of an expression. A variable is a symbol, usually a letter like X or Y or Z, that represents an unknown number. X is a variable. S is also a variable. A constant is a number that cannot change its value. It does not have a variable attached to it. In our example here, -3 is a constant. Each expression is made up of terms. A term can be a signed number, a variable, or a constant multiplied by a variable or variables. What? Well, let me show you. 2x squared is considered a term. 5s is also a term. And -3 is also considered a term. Parts of a term. Yep, in math we like to name everything. A numerical coefficient, or coefficient, is the number hooked to the variable. In this case, 2 is the numerical coefficient. X is the variable, and of course 2, the exponent. Let's look at 5v. 5 is the numerical coefficient, and v is the variable. Let's look at 7. Well, this is just a constant. It doesn't have a variable, so it's not a numerical coefficient. It's just a constant. Let's look at our first example. In this one, we're going to identify the terms, variables, coefficients, and any constants. So in the first one, 6x to the third minus 7x plus 1. 6x to the third is a term. -7x is a term. And 1 is also a term. What are the variables? In this case, it's just the x. And the coefficients? We have 6 and -7. What about 1? Well, 1 is a constant because it doesn't have a variable hooked to it. Now it's your turn. I want you to find the terms, variables, coefficients, and constants. Pause the video, then press play to check. Let's see how you did. So what are the terms? 1/2 w, yz, and -y. What are the variables? Well, we have w, y, and z. The coefficients, we actually have 3. 1/2 because it's hooked to the w, 1 because it's hooked to the yz, and -1 because it's hooked to the y. And what are the constants? We actually don't have any for this one. Great. Next, we want to identify like terms. Terms with exactly the same variables, including the same exponents, are called like terms. Let me show you some examples of like terms. 5x and -12x. We don't care about the coefficient. We're just looking at the variables. They're both x's and they're both to the first power. So those are like terms. Let me give you an example of unlike terms. 5x and -12y. Remember, we don't care about the coefficients, but we do care about the variables. Since I have an x and a y, they're not the same, so these are unlike terms. 1/2 z, 9z, 1.5z. Once again, these are like terms. We don't care about the number in front of them, just that they're all z to the first power. 1/2 z squared, 9z, 1.5x. Once again, we're looking at the variables. We have z squared and z. those are not like terms because they're not either both to the second power or both to the first power. And x isn't a z. Identifying like terms. Terms with exactly the same variables, including the same exponents, are called like terms. Let's look at some like terms. 5x and negative 12x are like terms. Right now, we really don't care about the coefficients. We're just looking at the variables, or the letters. Since these are both x and to the first power, they're like terms. Let's look at some unlike terms. 5x and negative 12y. Once again, we're not concerned about the coefficients yet, but the variables are x and y. They're not the same, so these are unlike terms. 1/2 z, 9z, 1.5z. Notice that all of the variables are z and to the first power, so these are like terms. 1/2 z squared, 9z, and 1.5x. Z squared and z are not like terms because z squared is to the second power and z is to the first power. Remember, they have to have the same exponents. And of course, x isn't a z. 3wx, 2wx, and 9xw. Let's just look at the variables. In the first term, we have wx. In the second term, wx. And in the third term, we still have a wx. It doesn't matter what order they're in. They're all the same. So these are like terms. 3wx, 2wx, and 9x squared w. Well, the wx are like terms, but when we have x squared and w, those are not like terms. Remember, they all have to be to the same exponent. Let's identify like terms in the list and put them next to each other. Let's start with 4xy. I'm going to look through the list and I'm looking for another xy. Here we go. Let's put them next to each other. Now let's keep going. Oh, there's another xy. And that looks like it. Now I'm going to go to the next term, 5x. So I'm going to write that down. I'm going to keep looking for my next x. There it is, negative 2x. Keep looking. Oh, and here's an x. Cool. Now we're going to start from the left again. I've already written 4xy and a 5x. Next, I have 3y. I'm going to keep looking, and oh, there's a negative 7y. Placing like terms next to each other is called collecting, grouping, or combining like terms. I want you to identify the like terms in the list and put them next to each other. Pause the video, then press play to check. All right, let's see how you did. We're going to start with 5xy. I'm going to keep looking, and hey, there's another xy. Remember, it doesn't matter what order they're in. yx is the same thing as xy. Let's keep looking. Oh, here we are, negative 4xy. All right. Let's start from the left again. I have an 8. I'm going to write it down. That's a constant. Hopefully you remember that. No more constants. So let's go to the y, 7y. Do I have any more y's? Nope. 3x. And then, of course, the last one, 2x. Did you get it right? It actually doesn't matter what order you write them in. So if you put the 8 first and then the 5xy's, it doesn't matter. Good job. We're going to simplify like terms. So the first thing we're going to do is we're going to put like terms next to each other. But this time, we're not going to put any commas. Let's start with 4x squared. Now let's look for another x squared. Oh, here it is. This time we're not putting a comma. We're just putting plus 3x squared. Let's keep looking. Oh, here we go. 2x squared, and that's it. Let's start with 4y. Whatever symbol is in front of the number is what you write. So we're going to write plus 4y. Here's another y, negative 3y. And finally, we have our constant 5. Next, we're going to add or subtract the coefficients, depending on the symbol. So we have 4x squared plus 3x squared plus 2x squared. Let's add their coefficients. I'm going to take 4 plus 3 plus 2. That's 9. Then we just put the x squared with it. So 4x squared plus 3x squared plus 2x squared is 9x squared. Next we have 4y minus 3y. We're going to take 4 minus 3, and that's 1. So we just write plus y or plus 1y. And finally, we just have the 5, our coefficient, so we just write 5. So when we simplified like terms, we end up with 9x squared plus y plus 5. Cool! Now it's your turn to try. You're going to pause the video, simplify like terms, then press play to check. All right, let's see how you did. Here's 4ab. Now let's look for another ab. Oh, here it is, minus ab. Do we have any more? Nope. Next, we have negative 2a squared b. So we're going to write it down. Do we have any more a squared b's? We sure do, right here. So let's write that down. Next, I have the constant 5. Do I have any more constants? I sure do, plus 4. And finally, just plus ab squared. Now, let's add or subtract the coefficients. So 4ab minus ab. That means 4 minus 1. That's going to give us 3ab. Negative 2 plus 2 is actually 0. So we're going to have 0a squared b. That's just 0. 5 plus 4 is 9. And then just plus ab squared. So we have 3ab plus 9 plus ab squared. Cool! Now let's make it a little more interesting with the distributive property. When I think about the distributive property, I think about making cupcakes. When we make cupcakes, we put the batter into the little cup holders. That's kind of like the distributive property. Well, here's the technical, mathematical way of explaining the distributive property, which might not make any sense. So let me just show you an example. What we're doing, remember, is putting the batter into the cupcake holders. So I'm going to take 5 times 2z. Then I'm going to take 5 times 7. That's the distributive property. Anytime I have a number or a letter next to a parentheses, I'm going to distribute that into the parentheses. 5 times 2z is 10z, and 5 times 7 is 35. It also works for subtraction. Once again, I'm going to put the batter in. 3 times 4z, and then 3 times negative 1. 3 times 4z is 12z. Negative 3 times 1 is negative 3. And that's really it. I'm going to do the first two. And then I want you to pause the video, figure out the last ones, and then press play to check. So let's look at number 1. I have a 4 next to a parentheses. So I'm going to distribute the 4 into the parentheses. So we're going to have 4 times x and 4 times 1. That gives us 4x plus 4. For number 2, we're taking negative 1 times 3x and negative 1 times 5. Remember, a negative is a positive. So we're going to end up with negative 3x plus 5. Now I want you to pause the video, do number 3, 4, and 5, and then press play to check. All right, let's see how you did. I'm going to take negative 3 times 2z and then negative 3 times 1. That gives us negative 6z minus 3. For number 4, we just have a negative. Well, that's the same thing as a negative 1, like we did in number 2. A negative times z, then a negative times 7 is negative z minus 7. We could also think about it as negative 1 times z, which is negative z, negative 1 times 7, which is negative 7. For the last one, we have 8 times 2q and 8 times 9. We're going to end up with 16q minus 72. Perfect! We're we're going to use everything we've learned so far and we're going to simplify like terms. First thing we always have to do is the distributive property, and it doesn't matter where it is. So hopefully you see that there's a -3 next to a parentheses. We need to do that first. So we're going to take -3 times a, then -3 times 1. -3 times a, and then we're going to take -3 times 1. Cool. So when I simplify, I have 7a plus 2 minus 3a minus 3. But we're not done simplifying because we have like terms here. We're going to take 7a minus 3a and then 2 minus 3. Did you notice that I put like terms next to each other? 7a minus 3a is 4a and 2 minus 3 is -1. Cool. I want you to do this one. Pause the video, do it, then press play to check. Let's see how you did. In this one, we have the distributive property right away. So we need to take 5 times t and then 5 times 1. The rest of it just stays the same. We're not going to distribute to those terms because they're not in parentheses. 5 times t is 5t, 5 times 1 is 5, plus 4 minus 3t. Once again, we're going to put like terms next to each other. 5t minus 3t, 5 plus 4. 5 minus 3t is 2t. 5 plus 4 is 9. Great. Write an expression for the perimeter of the triangle, then simplify the expression. Hopefully you remember perimeter means we add all the sides up. So that's what we're going to do. We're going to take x plus 5 plus 3x plus 1 plus 2x plus 8. Let's put like terms next to each other. So we have x plus 3x plus 2x. We're going to put the constants next to each other, plus 5 plus 1 plus 8. X plus 3x plus 2x is 6x. 5 plus 1 plus 8 is 14. So the expression is 5x plus 14. Now it's your turn to try. You're going to pause the video, write an expression for the perimeter of the rectangle, then simplify the expression. Plus play to check. Did you remember that this side is x plus y also? And this is 5x plus 2y? So we're going to take x plus y plus 5x plus 2y plus x plus y plus 5x plus 2y. We're going to put like terms next to each other. X plus 5x plus x plus 5x. We're going to put like terms next to each other. X plus 5x plus x plus 5x. And then we have plus y plus 2y plus y plus 2y. X plus 5x plus x plus 5x is 12x. Y plus 2y plus y plus 2y is 6y. How'd you do? Here's the self-quiz. You're going to pause the video, solve, then press play to check. Try to do it without looking back. Okay, let's see how you did. In number 1, the distributive property is in the second part. So 8x minus 5 stays the same. We'll have 3 times x and then 3 times 5. That gives us 8x minus 5 plus 3x plus 15. Let's put like terms next to each other. We'll have 8x plus 3x, negative 5 plus 15. 8x plus 3x is 11x, minus 5 plus 15 is plus 10. So when you simplified it, hopefully you got 11x plus 10. In number 2, you're asked to write an expression for the perimeter of the figure above, then simplify the expression. Remember, when we want to find the perimeter, we add all the sides up. So let's start. We're going to take 4x minus 7 plus 2x plus 4x minus 7 plus 2x plus x plus 9. Yeah, I went a little crazy with this one, but we're going to end up with the same answer. And it doesn't matter how you wrote it, we're going to get the same answer. Next, I'm going to collect like terms. So I'm going to have 4x plus 2x plus 4x plus 2x plus x. Minus 7 plus 9. All right. 4x plus 2x plus 4x plus 2x plus x is 13x. Minus 7 plus 9 is minus 5. 13x minus 5 is the expression for the perimeter of the figure. Number 3, we have to simplify again. For this one, I put like terms together. I'm going to have 5x squared minus 9x squared plus 7x minus x plus 12. 5x squared minus 9x squared is negative 4x squared. 7x minus x is 6x, and then we just have the 12. So when we simplify this one, we ended up with negative 4x squared plus 6x plus 12. Remember, you're not going to get good at this unless you practice, practice, practice. Thanks for watching, and I can't wait to see you in the next video.